For this particular problem, the first thing that you should be paying attention to here is that you are now dealing with a fourth degree polynomial function. So that means we have maybe an extra step in here, or some things that we need to take a look at. Again, we will start the same way as we have before. We start with Descartes' rule of signs and then rational root theorem, and then we'll go from there. Okay, so we'll take a look at our first one, and we have one sign change there, two, and then a third sign change. So that means we could have up to 3 positive roots, or less than that by an even amount. So that's one possible positive root. On our f of negative x, we go from a positive to a negative, but then we have the rest negative. So I only have one negative root. So I know I'm going to have exactly one negative root. Now I'm looking for 4 total on each of these. So this first scenario has 0 imaginary. And then the second scenario has 2 imaginary, which makes sense because our conjugate pairs theorem says that if we have one imaginary root, we got to have the conjugate as well. So, all right, next we'll take a look at listing our possible rational roots. And as you can see here, we have a pretty large listing of possible rational roots. So again, I'm going to use our calculator to graph this polynomial and give us a good visual. And what you'll notice is that we have 2 pretty discernible roots here on an integer value. You have a positive 2 and a negative 7. Now, here's the thing. In our next step, when we go into synthetic division, we can use either the 2 or the negative 7. And when we do that and we pull out that linear factor, we're going to be left with a cubic. And since we probably won't be able to factor that cubic, we'll want to use the other root to pull out an additional linear factor. So we're going to actually do synthetic division twice here with the 2 and the negative 7. Also, as you can see here, we're probably only going to have one positive root and one negative root, which through this scenario is going to leave us with 2 imaginary. So that kind of gives us a heads up of where we're going. I'm going to do my first synthetic division with positive 2. So I'm going to go ahead and work this out. And you can see that I did get a 0 off of that. Now, I'm going to go ahead and start this factoring process so that you can see the start of it and then how we're going to use synthetic division as a second time. And you can see that that cubic that's left over after the first factoring round is still pretty daunting. So we're going to want to use another root value that we can get from the graph to use synthetic again. And so now we're going to use that negative 7. Notice when I used the negative 7, I basically just dropped down the coefficients from the depressed polynomial to do my second layer of synthetic division. So I'll go ahead and work that now. Okay, now that you can see we have got a depressed polynomial, and notice this depressed polynomial is actually x squared plus 0x plus 3. We're not going to need that 0x, so we'll go ahead and factor this one more time in our problem. And as you see here, x squared plus 3 cannot be factored, so we can just go ahead and break this up and solve each of the parts individually. These 2 solutions we knew going into it because we used them from our graph and for our synthetic division. And then, of course, we have the 2 remaining solutions. And you can see that the plus or minus, we get the 2 imaginary solutions. So we have all 4 solutions. All right, so that's a good example of doing a higher degree polynomial, even greater than a cubic. So you could use synthetic division multiple times. Even if you went to 5th degree and 6th degree polynomials, you could continue to use synthetic division as long as you could factor out a linear factor.